Hi everyone, welcome back to my channel. I am Dr. Shahbaz S. So in this video, we will learn how to perform and interpret analysis of covariance, commonly known as ANCOVA in R. In the previous video, we tested the analysis of variance by using MANOVA, one-way ANOVA, two-way ANOVA, but in this video, we are going to perform ANCOVA, which is basically analysis of covariance. ANCOVA compares the mean scores of two or more groups while statistically controlling for the effect of a continuous variable called a covariance. For example, we may compare students' post-test scores across different teaching methods while controlling for their pre-test scores. This allows us to estimate adjusted group means after counting for initial differences. So in this way, the null hypothesis states that the adjusted group means are equal. And in case of alternative hypothesis state that the adjusted group means are not equal. So it means there is a significant difference. So we will also see the assumptions of ANCOVA before conducting the analysis in R. And in this video, I will demonstrate how to check the assumptions, conduct ANCOVA, interpret the results, compare adjusted means, calculate effect size, and see the results. Please like the video, subscribe to my channel, and turn on notifications for upcoming R tutorials. So first of all, we import our data in R. Okay, so I just give command to ChatGPT and I give data and request for coding to perform ANCOVA analysis. So first of all, we will import the data. We will copy this prompt, paste in R, then press enter. So a dialog box will open. So we need to select the data which is in the same directory we are working. So our data has been opened in R. So now we will consult our PowerPoint presentation to ensure the criteria, threshold values, and assumptions. We are completing group means after controlling for a continuous covariance. So ANCOVA adjust group comparisons for covariance. So in this way, we have a question like two teaching methods differ in final test scores after controlling for prior knowledge. And there is group factor which is teaching method A, teaching method A, B, and C. So with covariate, prior knowledge will influence outcome variable which is test score, final test score. So ANCOVA compares adjusted means rather than raw means alone. So in this way, our research question and hypotheses are research question after controlling for prior knowledge, do the teaching methods produce different mean final scores or not? So in this way, hypothesis we will see based on adjusted group means are equal, and alternative hypothesis states that at least one adjusted mean differs from others. Covariate should be linearly related to the outcome. So we have a data set of 15 observations, and we will see the assumptions like independent observations, continuous outcome and covariate, linear relationship between covariate and outcome, approximately normal residuals, no serious outliers, homogeneity of regression slopes, similar residual variances across groups. And by applying the test, we will see diagnostic and threshold values like method. In case of testing the impact, we will see p-value should be less than 0.05. And covariate, which is interaction impact, in case of p-value should be less than 0.05. And limit test, the p-value should be greater than 0.05 to check the variance equality. And the effect size, 0.01 indicates small, 0.06 is moderate, 0.14 are larger, indicates a large effect size. So now we come back to our R window and perform the ANCOVA in R. So we see the next prompt. We need to convert method categorical variable into factors. So for this purpose, we will copy this prompt and paste here and present. Our categorical variable has been factor. Okay, so now we check the descriptive statistics of our data. Copy this prompt and paste here, then press enter. So you can see the prior knowledge mean is 54.6 and final score mean is 71.4. So it means by using the method A, the mean score is increased from prior knowledge to final knowledge. So in prior knowledge the mean is 54.6 and in final mean is 71.8. So it has increased from 54.6 to 71.8, which is a significant change. And in V, you can also see there is a significant change from prior knowledge to final score. And there is also a significant change from prior knowledge to final score by using method C. So if you compare with method A, B and C, and then you can see method A, the prior knowledge mean is 54.6 and it is decreased by using method B, which is 54.0, and again it increased in method C, which is 57. On the other hand, we can also see that by using method A, the final score mean is 71.8, in B 63, and by using method C, the final score mean is 81.8. So there is significant change between AB, then BC, and then A and C. So we will check the comparison by post-op test comparison later. Okay, so now we check the homogeneity of regression. So copy this prompt and paste it. We get the results here. So we can see the residual minimum is minus 2.4082, median minus 0.0671, third quartile, first quartile, and maximum. And we can also see the estimates. The method B, the estimate value is 32.4104 is standard error, and the p-value is 2.272, and the value is less than 0.056. It means there is a significant impact of method B on test score. As well, we can see here method C also a significant impact on test score because the p-value, in this way the p-value is higher than 0.05. So it means method C doesn't make change in test score, and method C does not affect test score. If we see prior knowledge, the value of P is significant, so it means the prior knowledge significantly impact the outcome variable test score. And if we see the interaction method B with prior knowledge, so there is a significant impact, but the effect is negative. However, method C interaction with prior knowledge, so the impact is not significant because the p-value is higher than 0.05. So in this way we calculate the estimates as beta regression line. Okay, so next we perform the ANCOVA. We copy this from and then paste in R. Press enter. So we can check that the method degree of freedom to sum of square, mean square and F statistic is 68.309 and the p-value is significant because the p-value is less than 0.05. In case of prior knowledge, the p-value is higher than 0.05, which is not significant. So next, we check the normality of residues. Paste and enter. So according to Shapiro-Wilk normality test, the value of Wilk is 0.9471 and the p-value is higher than 0.05, so our data is not. Now we check the equality of variances. So according to finger-clean test of homogeneity of variances, the value of chi-square 0.70775 degree of freedom 2 and the p-value is greater than 0.05, mean we did not violate the law of homogeneity. I have already this package, installed package EM means, so we don't need to install again because we have already this package, so that is why it gives us error. So we just need to upload this package in R. We will upload and preload this package in R. So the package has been loaded in R. So now we can put the next one. Now we will calculate the adjusted mean pairwise. Okay, first of all adjusted mean, then we will check pairwise. Okay, so in method A, the mean value is 72, and method B 63.3, and then method C 81.3. So it means in first case, the 0 doesn't come between lower and upper class boundaries. So it means there is a significant change. There is also a 0 doesn't come, so there is also significant change. So also 0 doesn't come between the lower and upper boundaries, so it means there is also significant change. There is also, you can see here, from method A to B there is a significant change, as well method B to C there is a significant change, and method A to C there is also a significant change. And now we check the pairwise comparison. We copy this prompt and paste here. Okay, so you can see according to comparison method A to B, the estimate is 8.65 and the t-value is 5.366, which is greater than 1.96, and the p-value is less than 0.05. So it means there is a significant difference between method A and B of test score. As well, we can also see that there is also a significant difference of test score between method A and C because the p-value is less than 0.05. There is also, we can see here, method B to C, the value is negative 18.04 and the t-value is -10, and the value is again P less than 0.05. So it means there is also a significant negative change from method B to C. And in the end, we will save all the results in one Excel file. So we will copy this prompt and then paste in R. So R successfully created the R and ANCOVA results in Excel. So we can find the results in the same file. So these are the results from ANCOVA. So in this way we perform ANCOVA in R. If you find my video helpful, please subscribe to my channel. Press the bell icon.